Hello, the internet. Welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. Today, we are discussing one of my favorite projects, Binder. My name is Carol Willing, your co-host for Open Source Directions. This week, Anthony Skopatz is on a well-earned vacation. So also co-hosting with me today is a wonderfully creative person who's been pushing the boundaries of the Jupyter Notebook for years. Welcome, Tony.
Hi, Carol. I'm super excited to be doing this webinar with you because I'm a huge fan of Binder also. I use it mostly every week. Currently, I'm a data scientist at Quansight, and I'm a local community organizer in Atlanta. And I'm really looking forward to getting to know more about the project today. And with that, I want to welcome Chris.
Hey, everybody. My name is Chris Holdgraf. I work with the Jupyter project and also the Binder project, as we're going to talk about today. And I'm physically employed at UC Berkeley at the Berkeley Institute for Data Science.
Hi,
Great. Welcome, Chris.
Hi, I'm Min Regan Kelly. I've been working with Jupyter and IPython for a long time now. I'm currently in Oslo in Norway, and I'm looking forward to chatting about what we're doing with Binder.
Yes, welcome, Min. Welcome, Chris. This is a special treat for me because for the last couple of years, I've also worked on the Binder project. So I will try to be impartial as much as I can be about such things, but great job to everyone on the team. So this is the section of our program where we try and get folks to get to know you as people as well as the great things that we make. And so this week we have our famous Tweet of the Week section where each of our panelists presents a tweet that they've been enjoying recently. Chris, you're up first.
Okay, so I know that I'm supposed to choose a tweet to sort of humanize me, but I'm also being very on brand with the tweet that I found. Which is, for those of you who aren't familiar, there's a really great paper that came out on the archive a few months ago called, I believe it's 10 Simple Rules for Writing and Sharing Computational Analyses in Jupyter Notebooks. It's a really useful set of kind of practical tips to achieve reproducibility with notebooks. And just yesterday, they tweeted out that that paper had just been published officially in PLOS Computational Biology. So I recommend that everybody check it out. See how you can incorporate those ideas into your own practices.
Fantastic. Min?
Yeah, and I just wanted to highlight a cool tweet from Inez Montani for folks who know Spacey and other related things. She published a cool toolkit for making online interactive courses for teaching R and teaching things with R. And one of the cool things about it is you make this website that people can, with materials that you can run through with the execution is actually powered by Binder using a tool that she wrote.
Fantastic. I looked at it the other day. It looks absolutely fantastic. So hopefully folks will take you up on that. And Tony.
So this morning I was cruising around Twitter and I saw this really cool tweet from Jeremy Touloup from Quanstack, where he was showing a prototype debugger extension in Jupyter Lab. I'd be really excited to have a feature like that. I'm not sure how real it is, though.
I think it's getting there. I think they've got a pretty good demo. So with that, my tweet of the week is from Wendy, and it was talking about CodeLand conference's closing keynote, solving diabetes with an open source artificial pancreas, and it was given by Scott Hanselman. And she said it was both eye-opening and inspiring. And I encourage you to check out the links because it's just cool seeing open hardware and open software coming together to do good things in the world. So with that, the tweets are out of the way. And let's get down to Binder business. Chris, can you give us a brief intro to the Binder project?
Yeah, sure. So I'll describe the Binder project in four ways. One of them is, as a project, the goal of Binder is to facilitate and build technology and sort of grow the use of interactive, reproducible, and shareable computing environments. Another way to describe the Binder project is as a community of people, and that's an open source community that's distributed all around the world. Some people at universities, some people at companies, some people in the kind of general open source space. It's developed and maintained and supported by a pretty broad community of people all over. Next is as a set of open technology. So it's a collection of GitHub repositories, mostly under the Jupyter and Jupyter Hub organizations that sort of power the stack that we're going to talk about today. The two main ones being repo to Docker and Binder Hub, and we'll go into those in a little bit more detail. And then finally, it's also a collection of open services. So the most popular one that people often talk about is mybinder.org. And that's a large public instantiation of a Binder Hub that the Binder team runs as a service to the community and as kind of like a demonstration of the technology.
Great, and it's free too,
Yes.
right, Chris? Very cool. Okay, Tony.
Thank you for that summary. I understand Binder has a kind of long history. Why was it originally started? Like, what was the motivation and what need did it fill at the time?
Yeah, so Binder was started to enable sharing reproducible computational environments for folks using Jupyter notebooks. Since then, it's expanded to be a bit less Jupyter centric since then, and being able to be used with things like RStudio and other environments. But starting from the question of, I have some results or analysis, et cetera, maybe in notebooks, how do I make it as easy as possible to share those results in a form that's interactive for people? And additionally, how can we operate this as a public service? So starting from, I've done some work and I want to share it with folks. Jupyter Notebooks solve one piece of this because they provide a document format that while you're doing your analysis, it can encapsulate the code and the output in a format that you can send to somebody and they can rerun it and look at what you did and modify it and things like that in a nice interactive way. But sharing the notebook is only one piece of the puzzle. Software can be a challenge to install. So we've made your notebooks publicly. Software requirements. It can be a bit tricky to install, and especially research software can be, let's say, an extra challenge. So one of the big hurdles for sharing your code is actually reproducing the computational environment. So Binder adds to this concept of sharing, just sharing the code in the notebook with sharing a description of the computational environment, so that you can describe what's required to run the code, and then finally the software which we operate as a service to automatically create those environments so that you can share them, and then ultimately through the mybinder.org service, which is one instance of this, you can have a single link that lets anyone with just a click in a browser have a running run your analysis for free in just a few seconds.
Thanks, Min. That's great. And definitely it's like revolutionized education. Are there other alternative projects out there?
So because Binder does a few things, the answer to that depends a bit on which parts of Binder are important to you. So at its core, Binder builds tools for quick, easy, and free computational environments with Jupyter Notebooks. So from a Binder user's perspective, any hosted notebook service, and there are many, could be considered an alternative. So that includes Google Collaboratory, Microsoft Azure Notebooks, CoCalc, as the ones talked about most often, but there are lots more. And there's a recent article kind of summarizing and comparing different services.
Yeah, that was a good article.
So there are different trade-offs. Binder is one that has its own collection of trade-offs, and each one has their own. The main thing that Binder offers is this automatic environment setup. So you point at a repository that describes the packages you need and everything, and Binder automatically gives you an environment with everything that you need. And that's something that not a lot offer. They allow you to run the notebooks in a computational environment. Some have a more batteries included, lots of stuff already installed. So maybe you probably have what you need, but no control on versions and things, or you can just install after the fact, as is what people might do when you're just sharing it to someone's laptop. Just following human instructions for installing things after the fact. On the reproducibility side, there are projects like Wholetail and OSF, which offer more integrated tools for creating, annotating, and sharing research. And from a developer deployer perspective, there are fewer alternatives for deploying. If you're someone looking at Binder as, I would like to deploy a service like this, there aren't as many options that do similar things. Also, unlike many of these examples, the entire stack of Binder is open source stuff in and around the Jupyter community. So anybody can look at the full stack and reuse any pieces of that. And it's our hope that other organizations deploy their own Binder services for their communities. And there aren't as many options for people who want to do something like that.
Well, we're very grateful for y'all's contributions to open source with this technology. It seems like Binder does a lot for us. What is the technology that enables Binder to be such a general solution for programmers and scientists?
So Binder itself is mostly just sticking together other existing technologies. The first is Docker, which lets us describe the steps to create a portable environment and use it to run some code. And in our case, we're running notebooks or something similar. Repo to Docker is the tool that we use and maintain that looks at the contents of a repository and constructs a Docker image. And then on top of that, we have Jupyter Hub, which is a tool for deploying Jupyter servers or any web servers on behalf of many users on any computational resources.
We love Jupyter Hub. It's so powerful. It just took Min completely off.
Yeah.
Min, are you back?
I think I'm back. Yeah.
I think we missed some of the Jupyter Hub stuff.
Yeah, so Jupyter Hub lets you deploy notebooks or similar web-based environments on any computational resources on behalf of a number of users. And in the case of Binder Hub, those computational resources are provided by Kubernetes, which is a cloud deployment technology that lets us operate the Binder service in the cloud at fairly low cost and where the cost scales with demand for the service. Finally, tying it all together is Binder Hub, which is responsible for the page you see when you visit mybinder.org, and it ties repo to Docker for creating the environment and Jupyter Hub for actually running the interactive session to build images and launch notebook servers for people using the images it just built. And mybinder.org is just one deployment of this software of Binder Hub, but anyone can deploy Binder Hub on their own Kubernetes cluster, either privately or as a public service.
So much goodness, Min. Now, Binder had a life before it joined Jupyter. Who started the project?
Binder was started by Jeremy Freeman and Andrew Osheroff, who were at Genelia Labs at the time.
Very cool.
So now it's traded hands, and who maintains it now?
Currently, Binder is maintained by a team of Project Jupyter contributors, which we call the Binder team, some of whom are paid, some volunteer, some working at organizations that deploy their own Binder hubs, and we're distributed all around the world.
Excellent. Predominantly, what communities are the users and contributors from?
Mostly folks we see folks coming from science and education, and especially science education, but also members of companies around the world as well as freelancers. There's a particularly strong representation from the educational community, as many teachers use the Binder Hub at mybinder.org to share environments with their students for classes or workshops or things. There's also a growing contingent in academic publishing. We see the Binder project as a way to share reproducible analyses for papers.
So that's great. This project seems to be very inclusive to a lot of different people. Is the project participating in any diversity or inclusion efforts?
being part of the Jupyter Hub team in Jupyter, we've participated in the Outreachy program, which provides paid internships to underrepresented groups in open source software. And we've had a great experience so far working with them and are looking forward to continuing.
Fantastic. It was really great to see Outreachy being used, and it really had a good impact on both our project as well as the folks that participated in it. And now they're full contributors to the project. So that's awesome. They stayed around. All right. So now let's get to what we were all waiting for. And Chris is going to share a demo and walkthrough of the Binder project. And I'm going to let you take it away,
great.
Chris.
Thank you. Let's see if this screen sharing will work.
Fingers crossed.
Does that work?
Looking good.
Cool. So I'm just going to really quickly step through some pretty straightforward examples of what Binder repositories look like. I'm not going to go into a ton of detail of like the full complexity of all the stuff you can do in Binder because we have 3-hour-long tutorial sessions for that. But just to give you a taste of what we're talking about, as Min had mentioned before, one of the goals of the Binder project is to make it possible to reproduce and share environments that are stored online in code repositories. And the way that the Binder project tries to enable that is by rewarding people that follow best practices in scientific computing, best practices that are sort of already out there, community-defined tools or patterns that people already use in defining the environment needed to run some code. So for example, I'm going to look at one of the repositories from the Binder-examples GitHub organization. This is a collection of repositories that you can just think of as different patterns and ideas for how to use Binder. If I look into this example, I see a couple of things. First of all, I have this file, index.ipynd. And if I look at that, then I see it's just a fairly vanilla notebook. I've got some imports. I'm importing matplotlib and Seaborn. I'm plotting some figures. If this were a more complex scientific analysis, maybe I would also be, calculating some statistics, things like that. And then I also have a couple of environments files here. So I have a requirements.txt file. If I look inside that, I've got pinned versions of each of the packages that I have used inside that Jupyter notebook. And then I also have a runtime file here, which says this is the version of Python that's needed to run the code inside the notebook. And actually, this is all that we need in order to get Binder to build this repository. So what I'm going to do is just copy the URL for this repository. And I'm going to go to mybinder.org. And as we mentioned before, this is the public Binder hub that the Binder community runs. It's just one instance of a Binder hub, but it's one that's available to all of you in case you'd like to give the Binder project a whirl. I get this relatively straightforward form that just says, paste a URL of a GitHub repository, give me a branch, a tag, a commit hash, something like this, and optionally I can get a path to a notebook file. So all I'm going to do is just paste in the GitHub URL for the repository I just copied and click launch. So when I click launch, Binder says, okay, I've actually already built the environment for this repository. And I'll go into a little bit more detail of what happens if that environment hasn't been built. But basically what it says is, I know that there's already a Docker image up in the cloud that contains the environment needed to run that repo. And so I'm just going to spin up that image, create an interactive user session, and then dump you into that session. And so as you'll see here, I'm now taken to a Jupyter notebook file tree. If you look at the URL up above, I'm at hub.gke.mybinder.org. That's a Jupyter hub. And this kind of random gobbledygook here is my unique user session ID. So that ID was created on the fly for just me because I was the one that clicked on the launch button. And if I go inside this Jupyter notebook file, I can see that this looks the exact same as the notebook that was in the repository. And I can run all of these code cells, generate the outputs, and generally explore the results that were there. So that's the main pattern that Binder is trying to enable. So really quickly, I want to show you what happens if I then change one of the files in that repository. So let's say I go back here and I click on this little pencil. That's just going to take me to the editing screen within GitHub. And I'll just add a random extra dependency. And I'm not going to worry about pinning the version because this is just for demonstration purposes. So I'll just say adding pandas, and I'm going to commit directly to the master branch because of time constraints. Don't follow my lead on that one. So now we see I've got an extra line in this requirements.txt. So if I go back and I copy again the URL for this repository, I'm going to go to mybinder.org again. And now I'm going to paste in the same as before, that GitHub URL, and click launch. Now something different happens. Binder says, hey, I noticed that the GitHub commit is different from the last time that I looked at this repository. So I'm going to assume that the environment has changed and that I need to rebuild it. And now what you're seeing is the output of repo.docker inspecting that repository for its contents, determining the environment that's needed to build the repo, and then generating a Docker image from that environment. So here you can see the step where it's installing Seaborn and NumPy and some of the dependencies that we listed in there. Once it's finished building that environment, the last step that you're going to see is a pushing step. And this is where it's pushing the environment image into a Docker registry that Jupyter Hub will then be able to use on its own, so that in the future, when people click on these links, they won't have to automatically generate this environment. It will already be sitting there waiting for them. So I'm not going to look at that repository because I just showed you it. If there's time, I was just going to show one other example.
There's absolutely time.
So the other thing that I wanted to highlight is that, as Min mentioned, the goal of the Binder project is not just to facilitate the use of Jupyter notebooks. It's really to facilitate any kind of interactive computing environment that you can run via a web browser. And for those of you who are familiar with the R community, a really popular interface is RStudio. And Binder also works for sharing RStudio environments as well. And I should say that's true of a lot of other user interfaces as well. I'm just going to highlight RStudio here. So if you go to the binder-examples/R repository and look inside, you'll find a few different kinds of files that weren't there before. We have this install.r file, and if we look inside that, this is just a collection of R commands that install a couple of packages that we need to run, in this case, some R code. And we also have again, a runtime.txt file. But now if we look inside, we'll see that this says, I need an R runtime environment. And as opposed to Python, where we specified a version of Python, in that case it was 3.7, here we specify a date for R. And that's because a common pattern in the R community is to pin your dependencies to a specific date in time. And the state of all the packages in the MRAN repository are consistent given a date that you have provided. So in this case, we have 3 different Binder links, and I'm not going to click all of them, but it's going to be a little bit hard to see. The only difference between each of these links is in the final piece of the link. So in the top link, it says file path equals index.ipynd. And those are some extra parameters you can give with a Binder URL that take you to a specific file inside the repository. If I look at the one that's next to RStudio, in this case, I have something called URL path. And this will actually change the URL of the user once they launch their Binder session. In this case, it'll change it to RStudio. And that's because if I say that I want an R runtime in my runtime.txt, repo.docker will infer that I also want RStudio installed, because a lot of people that run R also run RStudio. So I'm going to click that link, and just to show you as a proof of concept, this is the Binder loading page, which is what you see if you click a Binder link, as opposed to using the Binder form to fill out all of that yourself. When my Binder session now gets launched, again, I'm running on the Jupyter Hub that's running on Binder. I have the same Binder user session but now I've got an interactive R Studio session, and I can, look inside my R code, play around with my analyses, and potentially reproduce them as well. So Binder also works with Shiny. It works with, let me see if I can stop sharing. So Binder also works with Shiny. It works with a number of other interactive computing interfaces. By default, Jupyter Lab, the Jupyter Notebook interface, and Interact are all installed, and you can use all of those out of the box. And what I would suggest is that you check out either the documentation for Binder at docs.mybinder.org or the other repositories at binder-examples, the GitHub organization, just to get some inspiration for the other kinds of things you can do with Binder.
Very cool. Thank you, Chris. I know I used Binder last summer to teach a group of high school students at Cal Poly what the interactivity within computer science can do. And we used IPyVolume and some of the really interactive TensorFlow examples. And so it was really fun not to have to go through the installation headache, but be able to have them engage quickly. And it's great. And it's great that it works on R and Julia and all the other things. So right now we're going to shift gears a little bit. We've been talking about what is there. And this is the part of the episode where we actually talk about where the project's going, what the project might need, so that members of our audience, if they want to contribute either time, money, code, they can do so. And so broadly speaking, folks, where's the project going?
Yeah, so I think that the best way to talk about the sort of future of the Binder project is in a few different kind of broad directions. Right now, our main priorities are first to continue growing the Binder community. And by that, I mean both grow the number of people using Binder, and by that I mean deploying their own Binder-ready repositories with configuration files and whatnot, as well as people who are deploying their own Binder hubs. The next is improving the kind of standards and best practices around specifications for reproducible interactive computing. As I mentioned, we look for particular kinds of files in a repository in order to figure out what's the environment needed to regenerate it. And that process of defining what those files are is a sort of community-driven process. So we don't want to define new standards for other people to have to learn. What we'd rather do is piggyback on pre-existing standards in those communities. And so continuing that and kind of growing the spec is another piece of our goal. And then finally, we also just want to make technological improvements to the open source software underneath Binder Hub and repo to Docker to either support different kinds of workflows or make them more robust or more scalable or more efficient. So I'm going to start off with the first one really quickly, and then Min's going to talk about the last two that I just mentioned. In terms of growing the Binder community, there are two really exciting things that I wanted to highlight there. The first one is what we're calling the Binder Federation. And one of the things that people often ask us is how we can possibly continue sustaining this, large, open, free service where we're letting people run arbitrary computing environments in the cloud and we don't ask for anything in return. That's a good question.
Yes,
and we want to keep
question.
on doing that. So while it doesn't actually cost that much to run the public mybinder.org service, and that's just because people run on fairly limited computing resources, it is still something that we want to make more robust and more sustainable over time. And so a few months back, we had the idea, what if there wasn't one Binder hub underneath mybinder.org, but there were actually a federation of Binder hubs that were all publicly run and that were made available to back some of the computation in the user sessions for people that hit mybinder.org. And so we partnered with a really great cloud computing company in Europe to be the sort of first test case n=2 example. It's a company called OVH, and they do a lot of really interesting stuff around open source and cloud computing and that kind of thing. So OVH offered to run their own Binder hub that lives at ovh.mybinder.org. And so now, whenever a user hits mybinder.org and launches a session, we actually split that traffic between the Binder hub that we run at gke.mybinder.org and the binder hub that OVH runs at ovh.mybinder.org. And what this lets us do is to distribute the load of computational resources that are needed on each individual binder hub. So the goal is that that's a pattern that we can replicate. And as we continue to get partners from other organizations, that they'll offer some of their services and some of their computing time in order to grow the number of binder hubs that's powering the sort of large public binder hub service. To that point, the main other thing that we're doing to try to grow the binder community and kind of make it more robust is to help support and grow the number of other organizations deploying their own binder hubs for their communities. This is different from federating mybinder.org in that we also want people to run a binder hub, for example, with authentication in front of it so that only people at like your university or your classroom can have access to the interactive reproducible environments. When you do that, then you can make decisions like, oh, I actually want this binder hub to have access to much more sophisticated computational resources, or to have, you know, fancier hardware like scalable computing, or access to privileged data, things like that. And so we're working with, you know, universities, companies, research groups, teachers to come up with ways that they can deploy a binder hub for their own groups. And in so doing, we can kind of grow the number of stakeholders who are contributing back into the binder ecosystem at the same time. So those are the main two things that we're focusing on from a community standpoint. And I'll hand it off to Min to talk a little bit about the technical things that we're going to cover.
That's great, Chris. And we're learning so much, both about community and technical stuff by doing these things. So it's really great that it's all done out in the open and other people can benefit from each other. So Min, you get the technical stuff?
Yeah. So one of the hard parts in repo to Docker that we're working on improving is the general fact that reproducibility is hard. Not taking the scientific reproducibility, just reproducing computational environments is hard. And from our perspective, the kind of tagline for repo to Docker is automating existing best practices. So we don't want to define a new specification for reproducible environments. We want to take what people are already doing.
We're waiting on with like anticipation as to what the reproducible environments will do. But yeah, we lost you for a second or two there, Min.
Yeah. So there are already ways that people are installing software that are well established in different language communities. The goal of repo to Docker and the design of repo to Docker is to just automate that process, both because we don't want people to have to choose to do what we tell them to, but also as a by having the mybinder.org service, encouraging people to do what their maybe more prudent colleagues are already doing. So by expanding the benefits for doing what's already considered a best practice. But this is a hard problem. And so one of the things that we're working on doing is finding out what these best practices are, finding out when certain things work well, when other strategies work well, and building a collection of documentation for describing how to specify your environment, what are the pitfalls of certain strategies. And one of the tensions in Binder is that Binder's used in a variety of communities for different purposes. And one is kind of living repositories that are always changing, keeping up to date with the latest stuff. And for those, weekly specifying your dependencies, it just says like, I need NumPy. If NumPy or Pandas updates in a way that I need to update my notebooks, I'll just do that, when I need to. And for those folks, it actually works best to only specify like, I need NumPy, I need Pandas.
Right, not to pin things and
yeah,
files and things. Yeah.
But then for folks doing scientific publications of, I have this stack of scientific software, I want to make sure that I get the exact same environment. Then you need to specify absolutely everything. And so pip has a version of that called pip freeze. Conda has a version of that called conda env export. But there's more to it than just the package that you're using, right? Repo to Docker is building a Docker image that's based on a particular base image. In our case, we use Ubuntu long-term support releases. And over time, repo to Docker gets updated and that base image changes. So even a strictly specified environment could stop working because of kernel changes and things. So depending on the timescale you're looking at, even frozen environments from the pip or conda perspective might not be enough.
Yeah, and that's a huge, I know lots of folks have worked many hours on trying to come up with, okay, what's the best way to do that? I mean, I think the Binder team, probably transparency of all the machinery is a key part of that. What are some things for the future that we might need to enhance that?
So one of them is allowing the repo to actually specify the repo to Docker version. Right, so a given version of repo to Docker will at least produce the exact same Docker file. Now, even that may not always be perfect, but at least it's the exact same steps running from the exact same version of Ubuntu. So that should last a while at least. And you can't currently specify what version of repo to Docker to use, but because repo to Docker itself can be run in Docker, we can, we're working on the strategy for saying like repo to Docker fetches a repo, realizes that repo actually says use this version of repo to Docker. If that's not the one being used, it can call out to repo to Docker again, and then actually build exactly the Docker file. So at least the Docker file is identical to one that's been built in the past.
Very cool. Just to give folks some context, how big is the actual Binder core team?
It's tricky to calculate core team, but if you look at, Chris can probably provide a link to our team page. I think we're 6 to 10, something like that.
Yeah, because I know when I had one talk, I think it was at Georgia Tech, I asked folks how many people did they think maintained Jupyter Hub, and they were like 50, 75. And I was like, at the time it was like, no, I think it's closer to half a dozen.
Yeah, there's 9 folks listed on the team right now, I think.
Yeah. So, as we're talking about roadmaps and how companies can help or individuals can help, time, money, working with the team to really understand the roadmap and what's needed is really critical. So I'll let you continue on the roadmap, because I know you've got more goodies to share with folks.
Yeah, for contributing on repo to Docker, the absolute best thing is presenting your use cases and describing how it works well or doesn't. So, describing idiosyncrasies of software in your community and requirements for whether you're on the deployment side or on the user side. Bringing user stories and things of this is how we want to use it. This is why it doesn't work, or this is why it's already great. Are extremely useful, and especially if you're in a language community that we don't support yet, right? So, we support installation with Julia and R and Python and Nix. Then contributing build packs for your language community, or contributing to the build packs for the existing build packs for your community is really useful, because the idea of automating existing best practices means we need community members who are helping define what those are.
Right.
Repo to Docker wants to follow the community in rather than drive what it means.
That's great.
And then on the other side so that's kind of on the strict reproducibility side, expanding the scope of what we can do, like what I was just mentioning, is in general, what requirements can't easily be specified yet with what we have, and that's really the question that guides a lot of the future development in our project, from Binder to to repo to Docker. So we talked about the language communities and stuff, but there's also more than one way to store your repository. So for a long time, initially with the original binder, the only thing supported was GitHub repositories.
Right.
The binder 2.0 that launched 2 years ago, we've expanded that over time to any Git repository. And then more recently, we've expanded that to DOIs published on, so archives published with a DOI on Zenodo. But there's lots of different ways that people might publish an archive, especially in the scientific publishing community. And so repo to Docker has this abstraction of kind of content providers of, there's an archive somewhere, how do I find out what version it is and get the files so I can build it? So if you're in a community where you don't use Git or don't use Zenodo, but you publish things somewhere else, then that would be a great place to contribute.
I can honestly say that the day that Binder started supporting GIST, I exclaimed out loud, it changed the way that I do reproducible research. I hate folders, so I put a binder to all of my GISTs now, and I feel guilty. Does making more binders cause problems for you all?
It makes some of our charts slower, but not on the scale of what any one person can do.
Good point.
Okay, folks, you heard that. Please help us expand capacity for this project so Tony doesn't take it down. I think one of the things we've been seeing is more industry, like research areas kind of clustering around a particular topic. How would Binder's roadmap help them?
One interesting deployment is Pangeo, the geosciences cloud computing tools development group. They have a very similar mission of making it easier for scientists in their domain to use all the computational resources that are available, and they use things like Jupyter and Binder to expose those computational resources to those researchers. And their use case, so Binder, mybinder.org gives you very, very little, partly driven by financial constraints. We can't afford to give you a bunch of GPUs and a lot of computing resources that might be necessary for,
Yeah. So while Megan is frozen, GPUs are expensive. And are you back now with us, Min, or are you still somewhat frozen?
Yep.
Oh, now he's completely gone. And that's what, GPUs are expensive. And I think as part of an open source project that is a nonprofit, we were just talking about the expense of GPUs, and it's good to see you back. So I will let you continue.
Yeah, Pangeo has driven because some of the data analysis that Pangeo folks deal with needs more resources, but not all of it does. So they're driving new features in Binder that we're working on figuring out what's the best way. And that's not just, so we've described software requirements. Like I need TensorFlow to do this, but I might need a GPU or I might need 3 gigs of RAM.
Right.
Kind of specification that we're exploring. How do I say that I need these resources in order to run this repo at all? And that's a new kind of question, because for repo to Docker, we're building the Docker image that's kind of a portable context that you can run the same Docker image with GPUs and 10 CPUs and 10 gigs of RAM, or you can run it with just a tiny bit of resources. The resources are kind of a deployment question. So then there's that, when talking about how do I specify that I need these resources, where do you specify that? And does this become a feature of repo to Docker, which is creating a Docker image that can be run with any resources, or is this a feature of Binder Hub, which is the code that is responsible for taking a repo and deploying it somewhere? So ultimately, so it makes it a little little tricky because of these different pieces of software solving different problems. How do you answer this? Where does the specification live, and which software is responsible for interpreting it?
Yeah, and I think a lot like the authenticators and spawners and Jupyter Hub, a lot of this we learn as we go and from the community input. So it's great that you and Chris were able to share the roadmap of where we're going. Since we're about 10 minutes of the hour, I want to get a few questions that folks have asked. And hopefully we can have you back in like 9 months to a year, because I know this project is moving really quickly, and it would be great to kind of see what's new in a little while. So yeah, so the first question, what are some of the interesting use cases that you've seen for Binder?
I guess I can take that one. So I think that there are a couple of different ways to define that. One of them is like an interesting, field or an interesting usage of one Binder repository. For me, the thing that is really exciting, because it's also something that a challenge that we've had at Berkeley, is in using Binder to kind of power interactive computing that lives underneath maybe more like traditional published artifacts. So there's a really interesting project called Phoebe Lab and a related one called NB Interact. And what both of those projects do is they connect to a Binder kernel remotely. So they don't send a person to a new page like what we showed you in the demo. They, under the hood, ask Binder for a kernel, and then they allow a user to run code against that kernel wherever they were before. So if you're on a page that has like a field for input, you can use something like Phoebe Lab to basically ask for a remote Binder kernel, run the input in your static web page against that kernel, and then display some interactive outputs beneath it. And that's been used for some really interesting things like interactive online textbooks, where each page covers some sort of computational idea, and then the person that wrote the textbook lets people connect remotely to a Binder kernel so that students can kind of immediately dive in and start interacting with things if they want to. That's pretty cool.
That's awesome. Yeah, that's cool.
So hopefully when we catch up with you guys in another year, I'm sure we'll hear about growth, but maybe it would be nice to know how some institutions can become part of the Federation to help you guys grow.
Yeah, I think that the best way to learn more about that is to check out the Binder Hub Read the Docs page. So the documentation for Binder Hub itself has a lot of information for how you can deploy your own Binder Hub service. And it's, a lot of it's technical and kind of digs into Kubernetes and how to get the Docker registry set up and all that stuff. Another part of that documentation talks about the Federation itself underneath mybinder.org. And there's a section there that, both it says who's currently in the Federation, what does it mean to join the Federation, what are the kinds of things that you could offer that would be helpful, and then what are the ways that you can get involved. So I'd recommend checking that out and kind of stepping through the information that's there. The main thing to note is that there are basically two really straightforward ways that you can help the Binder Federation. One of them is to provide computing resources that you give the Binder community control over. So that would be like, I am a researcher and I have a bunch of cloud credits, and I'm willing to let the Binder team use those credits in order to power a Binder Hub. The other one is if you would like to actually run your own Binder Hub and then kind of plug in on your own. And for that, I think that what we recommend is that you just open up an issue on the mybinder.org-deploy GitHub repository. That's the repo that contains the configuration for mybinder itself. Say, hey, I'm interested in helping out. I'm at an institution and I think that we have the capacity to do this. And then what we'll do is assign a subdomain for your Binder Hub deployment. So gke.mybinder.org or ovh.mybinder.org would be something like that. And then it's actually a fairly straightforward configuration change on that repository once your Binder Hub is up and running to start splitting off traffic and sending people your way. So please do reach out, and we're happy to work with people on figuring all that stuff out.
Great. The next question comes from Chris, who's in our audience. And one thing we've run into using Binder to teach quantum programming workshops is the need to specify requirements for multiple programming platforms, i.e. Python and .NET Core. Is this already supported in repo to Docker, or are there plans to add this support? And thanks for the awesome project.
So there are a couple points to this. One is that .NET Core is not one of the supported environment types, so that would need to be something that's added. So if you could open an issue on repo to Docker to describe what's the normal way to specify the software needed for this, then that would be the first place to start. The second is that composability of multiple environments works sometimes and should work more often. Because of the way repo to Docker is put together with build packs that are classes that are subclass, and only one build pack is used at a time. But many of the build packs are kind of inherited in a certain order. Often Python and something else usually works, but something not Python and something else not Python maybe doesn't. Another answer is if all your stuff is packaged with Conda, no matter what language it's in, then you can create a single Conda environment specification, and that will work.
That's a great.
So the answers are like yes, no, maybe, and in the future.
Can I give two other quick thoughts on that? So Matthias just mentioned in the chat room another point, which is that there's a safety valve in Binder, which is that if you don't want to use the sort of traditional configuration files that we've mentioned, or you've got a particularly complex environment, Binder also supports Docker files. So if you add in a Docker file, and that's something that you'll need to do some very specific things to make sure that it runs with the Jupyter server and whatnot. But if you meet those needs, then you can populate that Docker file with whatever you wish and set up whatever ridiculously complicated environment you would like to. The other sort of safety valve that's within the configuration file workflow is if you include a file that's simply called post build, that is effectively a bash script that will be run after all of the installation is finished. And you can put in kind of arbitrary commands in that if you'd like. Some people use it to download data sets. Some people use it to initialize models. You could also use it to set up other kinds of environments as well. You can also use it to mine Bitcoin, but we will catch you.
But we discourage that. Okay, one last quick question. Tony, you've got it. And then we're going to start wrapping up.
So how does somebody find out more about how to use Binder?
So we'll post a couple of links in the chat room if we haven't already. But there are a few different ways that you can do that depending on how you'd like to get involved in the Binder project. If you're interested in learning more about how to use Binder Hub as deploying your own repository and whatnot, I would check out docs.binder.org. There are also some other really great resources that don't focus explicitly on Binder, but include Binder as a part of other reproducibility practices. One that I can recommend is called The Turing Way, which is an open community that has they've developed a handbook for best practices in reproducible science. They include Binder as a part of that. And that's maintained by a really excellent community of people that's based out of the Turing Institute in the UK. If you're interested in learning more about how to deploy your own Binder Hub, as we'd mentioned, binderhub.readthedocs.io is a really great resource. It contains both information on the technical side as well how to set up your own, as how to join the federation. And then finally, if you're interested in just learning about the Binder community and the team dynamics and whatnot, check out jupyterhub.readthedocs.io. jupyterhub-team-compass.readthedocs.io, which has a lot of useful kind of community and team information from the Binder and Jupyter Hub repos. And then I believe there's also on the screen a couple of helpful community links to get in touch with the broader Jupyter community in general.
Thank you.
Fantastic. Well, thank you, Min and Chris, for sharing all this stuff. Tony and I definitely enjoyed it. Now's the part where we get to have 15-second soapbox to rant. It's usually a rant, but since Tony's not here, Anthony's not here, I'm going to make it rants or raves because I'm the eternal optimist. So rant or rave about anything that you want. And Chris, it is your soapbox.
So I'm also not really ranting. It's more of a rave, although I can turn it into a rant if I need to. I want to draw attention to a really interesting program that's run from the Mozilla Foundation. It's called the Open Leaders Program. It's run by a woman named Abby Mays and a man named Chad Sensing, I believe. It's a really great program. It's a couple of weeks long, and it basically just covers a lot of best practices and how to run communities in an open, inclusive manner, how to grow them, how to make sure that they're sort of sustainable and equitable, and also effective and productive. I find it to be really useful in not only learning about open source communities, but also just running your own teams or your own local communities effectively. They have applications out for the next round of Open Leaders Fellows, and I recommend that you check it out.
Great. Min?
Yeah, I guess I have a slightly more traditional rant. Just please don't pin a subset of your requirements. Pin all of them or none of them. Just, yeah. The worst thing you can do is
That's
pin
classic Min.
only your direct dependencies, because their dependencies can float out from under them, and yeah, that's the worst.
Great rant and great tip. Tony? We might have lost Tony. So while Tony returns, my rant and rave is there's been 3 great whites off the coast of my local beach in the past 3 days. And the cool fact, though, is there's a shark lab at Cal State Long Beach that has a project on using drones to find, research, and report on great white activity. So I'm thinking there might be some cool notebooks that could be hosted in Binder. And so, Tony, your rant or rave is?
If reproducibility is your thing, then it's a lifestyle. And I encourage people to practice by making reproducible blog posts with Binder. Give it a go.
Okay, and thanks again, Tony, Chris, and Min. That's all the time we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including Binder, you can find all the project roadmaps at quansight.com/projects. Chris, Min, where can people find you and Binder?
You can find the service at mybinder.org, the code in the Jupyter Hub org on GitHub, and community in the Binder section of the Jupyter Community Forum. I'm MinRK on GitHub and Twitter, and Chris is yeah, go ahead.
Yeah, and I'm C Holdgraph on Twitter and GitHub as well.
Yeah.
And thanks again for joining us. It's been absolute pleasure to talk about Binder. Join us again next episode for a star-studded discussion on Vega. Bye,
Thanks,
folks.
everybody.